This is my Walco mill that I converted to CNC 5 years ago now, and I've had a chance to review how things have gone and what I've made in the way of changes. The mill is pretty robust. I haven't really had any problems, and most of what I've fitted has worked well. The one thing I didn't have for quite a while was a means of measuring the RPM. I'd fitted a slotted wheel and never got that to read properly, so I've relatively recently fitted a magnetic counter up there, detector up here, based on a magnet which is fastened to the underside of this disc, and you can probably just see it coming around just in there, and that records the RPM well, and that's therefore gives me the opportunity of having a second one which I recently put in at right angles, and that runs down through to the main board. So I've got a reading on the main board, and I've also got a reading on the separate display here, and of course they show the same figure, so that confirms that they're both okay. There isn't a lot of room to mount a detector. There's this spring arrangement at the top here of Belleville washers, which is used for the changing of the tooling, and I've got a Tormac TTS system on here, but I made up myself, 4 separate cylinders. It worked well, except I ended up getting a leak which was a bit mysterious, couldn't figure out where it was, and in the end I found, when I took it apart, that at the top here there was one O-ring on this seal here that had got pinched when I put it together previously, and it was leaking, so when I took it apart I just simply corrected its position to where it should have been, put it all back together again with a little bit of extra grease, and that now operates absolutely perfectly. It's as good as the day I put it in, and I have a manual valve on the side there. So that's needed nothing done to it, except I did replace this with a proper Festo valve on here, and then I took advantage of the fact that I've got a supply of compressed air to here and ran a separate pipe through to the other side of the head here, and I've installed an oil mist system. So I'd certainly recommend anybody who's interested in putting their own Tormac TTS type system in. I don't see any downside to it. Works very well, and that has caused me very little problem. It doesn't seem to slip, and works very well. And I've started to make 1 or 2 refinements to it to make it a little bit more sophisticated, I guess. In the past, all of my cutting has been done by zeroing out the work coordinates and zeroing out I need soft limits on each axis in each direction. So I have a soft axis at this end of the table, a soft axis at this end of the table, a soft axis here and a soft axis there, and one on the column, because there's not really much point in having one coming down. It either buries its head in the top or I can't get things underneath. So that's what I've decided to do. Then I also wanted to be able to, as well as having the soft axis so that I couldn't go with the table up and into the end, which I've done before, and I couldn't get it going this way and hitting something that direction. I found it quite difficult to understand how the soft limits had to work together with the homing switches and or sensors, and I thought I would do my best to try and show how you can achieve it relatively easily to take advantage of using probing. And I fitted a proximity sensor on the Z-axis in this position. This is the underneath the milling vise, which is here. I've got here is one of the proximity indicators that goes up against the stop here, and at 4mm off this stop it switches on, and a little red light comes on and it then activates. So basically the whole table moves in that direction until it reaches the stop, and that seems to work perfectly well. So that's doing the homing. Then underneath here you can see the same proximity indicator indicates on when the sensor reaches this part of the table. Now I've got a close-up showing through here. You can see the sensor that does the y-axis. So if I just put something in front of it, you'll see the red light flicker on down at the bottom of the screen, and similarly the one on the x-axis, you'll see that switch on. I'll now show moving the X table across to the left here. So this point here will just about reach here, and it will stop with the soft limits. Get it the right way, there we go. Now that's stopped, and the reason it stopped is the soft limits, and I'll bring you across with the camera so you can see what the screen says. It says a machine axis positive software limit was reached, the axis was now stopped. Okay, and you can start moving it again once you've clicked and signified. So I can now move it back. So if I move it back this way, I can hear you probably saying, what happens if you've got a homing proximity sensor coming up against stop, which would normally trigger when you're doing a homing cycle? What happens if you do that and just drive it in without actually being on a homing cycle? And the answer is to watch this video, because that's what I'm going to do now. Just jog us straight into where the sensor is. Here it comes, and it stops 4mm away. It's the soft limits means that it can't reach the sensor, but if the sensor's switched on, it will work for homing in the same position. The alternative would be to use the sensor there as a limit as well as being soft limits, but that gets more complicated and involves setting up another pin, so decided not to do that. I'm just leaving it set up this way, and of course, having run into the soft limits, I then have to remove the warning sign that comes up on the computer. So I'll just move you across and take the warning sign off. That's gone. So now we're in the position of coming across here and jogging away. If you set hard limits on, I've discovered if you make that a hard limit and it comes up to the stop and stops because of it, it then produces a different warning, and you have to go into the system and go to override limits, which is 2 boxes above the reset box. But I've not actually done that. I just checked how it worked, but that's I'm not using. How to home the axes. So if I want to home the x-axis, it will come across until the sensor reaches the stop here, and then it will home it. So those are the settings on the x-axis on the first line there, and you can see the work coordinates 2.1 and the machine coordinates 3.0. So if I home them, I'll perhaps show you which button I press, because it took me a while to realise that that was the one that I need to press. That's the home button, so that now references that. I'll put this back here. It's coming along. You'll see it reaching the sensor, which has now appeared. And it's reached the sensor, and I've asked it to go back and set it into the middle position so it reaches the center of the table. Now I can do the same on the y-axis. Let me just click on the sensor there, and the table moves back until it reaches the sensor down the bottom here. It then goes back to the middle position. On this particular mill, I've got more travel to this side towards the front of the mill than I have towards the back. Right, now if I lower this down, I'll lower the z-axis down till it's below the level. Now if I want to probe this so that this is centered, I'll show you the probe screen that I use. So it's at the inner that's better. So it's the inner circle, and I've set it at 65mm for position 1 and position 2, on the Y and X axis. They're both homed, and it won't work on the probing unless it is homed. And this is where it shows the calculations in the screen there. That's the diameter of the probe. That I discovered had to be 1, but it didn't work otherwise. And those are other figures that I'd found on somebody else's site. So anyway, they work. So if I now get it to probe, start probing is hidden over here. You can hear it now working. It's running through the probing routine now. So it's done X in rapid movement, and it's now doing Y, and that's its slow speed when it's doing it. So it does it rapid first, then slow, and once it's done the whole thing, it goes over it and does it a second time, and all the calculations are shown in these squares here. And then, having done it once, it runs it through a second time to prove that it's accurate. Right, so that's now centered. So what I'll do now, I'll just run this up a little bit higher so you can see it a little better. I'll just move this on both axes and center it again. So I'm going to reprobe it in the center. I'm starting probing now. Fortunately, this has got an LED light which helps you see what's happening, and you can tell the moment it's touched. And that's the slow movement. Okay, that's finished, and the two readings for the inside of that cylinder are 48.0364 and 47.9348, so very close to being spot on 48 millimeters. So let's just check that and see if we're somewhere near right. 47.9, but I'm sure it's 48. But that works very well. I discovered after I've only just used it fairly recently, I've had it a long time, and I think it's quite reasonably expensive Renishaw probe, and unfortunately I had difficulties getting it running in the first place, and there was two pieces of swarf inside connecting on the electrics, which made it so that it didn't register properly. And once I'd removed those, then worked. And the other thing it needed was centering, and I discovered that sitting up underneath here are 3 screws which you can get to with a small Allen key, and if you run the probe up against a wall of something like this and turn it round, you can see if the point of that moves at all, and you can check to see whether it's registering on the LED on the top there. So by turning this round and adjusting the screws underneath, you can remove any error, so there's hardly any error in that at all, which was I'll say it was very pleasing when I found that, because that was something I was worrying about. So I can now home the axes. I can probe on X and Y. I've got safe limits on soft limits on the X, Y and Z. So that is excellent improvement on what I had before, and I've also got RPM showing from the RPM sensor, and that runs through into the computer as well. So that's the improvements that I've made recently. This is my Xbox360 controller, which at first glance you probably wouldn't realise it's a Wi-Fi one. There's a box at the back with a battery, and there's a transmitter that sends a signal to a USB pickup which is plugged into the computer. So I can control it using this separate from the machine. I've got control of the A-axis on plus and minus. I can press to stop the mill on an emergency direct from the handset, clear the reset if I need to, and there's a jogging up and down control, so they're very important. If you're on one axis and you want to slow it down, you can press the minus sign and it will slow down. So let's do that. Now if you want to do something, that's using these two buttons to slow it down to make sure I'm in focus in the shot. And the final speed, I think I'm right in saying, is 80, but you can change it on the screen by using the flyout page. So that's up and down. Now, one thing that I discovered by this, nobody's mentioned this either, if you want to machine something, if you're using the one axis like this, it's quite easy to make a mistake and suddenly find yourself driving the second axis as well. But to avoid that, if you press the silver button, the silver button locks it on that, and it's locked until you press it again, which unlocks it. So I found that very, very helpful to be able to do that. That silver button did something I didn't realise it did. I don't use that and I don't use that, but all the settings here I've got on a page which I can put up on the screen. This is the page of the settings for the Xbox controller that I use. I'm going to take you through the setup screens just so that you can see the information that I've used on mine, which you may find helpful. Mine runs with the setup shown here. The general setup screen that has the homing sequence, which you can alter, Z, X and then Y, because obviously you want the X set up so that it doesn't destroy anything by moving from side to side or front to back. Axis setups. I go to the X axis first. Now these are things that you might find useful that I've shown here. The number of units that I'm using, that's in millimeters, and the soft limits, for example, is minus 170 for the minus direction, and for the plus direction 170, which means 340 millimeters of travel. So your bed may not be the same size, or won't be the same size as this, so your figures will be different, but that's the general principle on which it works. The home pin I use is pin 6 on port 2, and the homing speed is there. That seems to work alright, I don't have any problem with the speed. So if I now move to the Y axis, and you can just check on my figures there. And the Y is very different to the X, because I've got, as I explained further in the video, a table that's it got more travel on one side than the other. I've got minus 121 in one direction and 85 in the other direction. On home pin 4, port 2, and the backing off is to 121, because that's the position where the mill centers on top of my vise, because that's where I like it to go to once it's been homed. Just go back to the x-axis. That goes back, that's homed to 170, which is halfway across when it homes back. And the z-axis, that is different again, because I'm only really worried about the topmost homing limit that has a right offset on homing of 50, so it ends up 50 down, but the unit is minus 80 backing off, and its limit is 170 minus and 140 plus, but as I say, that has to be established by trial and error on your own computer. I'm running here the Z-axis on home pin 5 port 2, and then finally I've got a rotary axis which is nothing special, and it's not doing any homing or anything, and I just set it to 0 degrees when I first set it up to use it. And the spindle, that is on index pin 3 port 2, and it's one revolution, one contact every revolution, so it's one prescaler, index prescaler. I'm not using any pulse width modulation control, so I'm not using that, and I'm not using a spindle direction and control either. Oh, I'll go to the probe page first. Go to the probe page. These are 2 pages of probing setups. So far I've only used the simple probe just to index off edge find effectively, and that's quite simple to set up. And this one took a little while to get sorted, and that's using the inner circle. And I've dealt with that separately. I'm hoping that this file will be of some use to those wanting to set up soft limits to their computer, and to get better use out of their CNC mill with little extra cost.